Conditional branching statements. The prerequisites are topics which are to be expected to be familiar with are identifier and keywords. One should know how to create identifiers, the naming conventions, difference between the identifiers and keywords, assignment of value to identifiers, how the value is assigned to identifiers, taking a value uh, from the system as an input, and how the system provides an output, the arithmetic and relational operators, expression evaluation, how an expression is evaluated into values, uh, then sequential and execution of statements, how the statements are executed in a sequence, one after another. Now, what are conditional and branching statements? Statements that help to jump from one part of the program to another depending on whether a particular condition is satisfied or not. So here we have already seen that sequential programming is that one after another all the statements are executed in a sequence, but in branching we have a certain condition. On the basis of this condition we choose a path, either either the path which is on the true side of the condition or the path which is on the false side of the condition. Only one path will be chosen. One of the block will be executed, not both. This is called branching. So sometimes when such situation arise, that we have to execute some instructions basis on a condition. Uh, so then we use conditional or branching statements. The keywords which are used to do so are if and else. In Python, flowchart would be like this. There is a test expression. If this expression evaluates to true, then if the body of if will is executed. And if the expression evaluates to false, the body of else is executed, but not both bodies. Means both blocks will not be executed. Only uh, either if block will be executed or the else block will be executed. Then the statements following the if or if else block will be executed. Syntax would be like this. First we write the if keyword, then a condition in front of it, and then a colon. Colon in Python marks the starting of a block, and a block has a different indentation. Suppose if has a block, then if block will have an indentation, supposedly 4 or 5 spaces from the starting of if. Similarly, the else block will be in same indentation of if, but the block of else, the statements which are part of else block will have the indentation 4 or 5 spaces from the starting of else keyword. This is the syntax. For an example code, we have an identifier num, we have a number in this, value is assigned to it. We want to check whether this number is even or odd. So in condition of if, we check whether this number is divisible by 2 or not. So for that we have written an expression over here, num %2, this modulus operator will provide us the remainder, and if this remainder is equal to 0, then the number is divisible by 2. So if this condition is true, then if block will be executed. The statement written inside the if block, which is print even number, this will be printed. Otherwise, if this is not so, means the number is not even, the remainder is not equal to 0, then the else block will be executed. And this statement will be executed, print odd number. But in any case, both these statements, even number and odd number, will not be printed. This is how an if else works. Now we have an if else ladder. Flowchart is like this. We have test expression 1. If this evaluates to true, the ifs block will be executed, and then it will get out of this ladder. The statement just below if else if ladder will be executed in the sequence. But if this test expression 1 is evaluated to false, then we check the second expression whether this one is true or not. If this evaluates to true, fine, the statement 2 will be executed. But even if this is evaluating to false, then next text expression will be evaluated. Similarly, so on, till the last text expression else block is executed. So this is the syntax. If the condition which is to be checked, then the statement which should be part of this if block, then elif keyword and a condition which is to be checked, second condition, and then the second statement which should be executed. Similarly, elif blocks can be there as per our need or requirement of our logic, and the last else block. Then in the end, uh, we can have other statements after this if elif ladder. A simple example code where this if elif else ladder is suitable to be used. Supposedly we have range of values and we want to check in which range the value lies, then we can use this. Suppose we can grade our students on basis of their marks. If marks is less than 0, we should print the message invalid marks. Elif marks is less than 33, the message of fail should be printed. Elif marks is less than 100, that means it is greater than 33 but less than 100, so pass message will be printed, else the invalid marks will be printed because marks cannot be greater than 100. So this is how an if elif else ladder works. Now we can use if without an else. Only if can be used in programming language. Suppose we have a text expression. If evaluates to true, then we can write the code or statement which should be part of the if block that should be executed on this expression being true. Otherwise, we can simply just move on to the next statements after this if, skipping the else part. Syntax would be like this: if simply a condition and the block of if which should be executed in case this condition evaluates to true. And skipping the else, we don't need to write the else part here, and we won't even get uh, an error for this. Then example code. Mostly this should be used. This is used for counters or any other purpose where a condition is to be met and we have to do some uh, computation on basis of some condition, but we don't need to do anything else in case this condition is not met. So here we are counting a number if its number is divisible by 3. So counter is initialized with 0. If not, num%3. Num%3 value, if it evaluates to 0, means num is divided by 3 and the remainder is 0, then it is inverted by naught. That means if number is divisible by 3, then this condition of if will evaluate it to true and the counter will be incremented by 1. Finally, the counter can be printed. Then there is nested if else. We write if we check a condition, we write a condition in front of it and check whether it is true or not. Then we write some statements which are part of if block. But what if another if is a part of this if block? That is also possible. So this is having a if inside an if. First expression is evaluated, the test expression. Then if this evaluates to true, another nested test expression is checked. If this is true, its if block is executed, the nested if, the block of nested if. If it evaluates to false, the body of nested else is evaluated, and then to the statement just below the if and else. Syntax would be like this: the outer if is in red color. If the condition for the red if is it evaluates to true, then condition for blue if is checked. If it is true, the statements are executed. If condition for blue if is evaluates to false, then blue else will be executed. And if the condition of red if evaluates to false, then it directly executes the red else, skipping this block of if. A simple example code could be like this. Suppose there is a number num. We are checking whether it is multiple of 2, and also is it a multiple of 3, or just simply not a multiple of 2. Firstly, we check whether it is multiple of 2. If num% 2 is equal to 0, so this condition will evaluate to true if the number is divisible by 2. Then this if will be executed. We will print a message the multiple of 2, and then another nested if is in this block. If num%3 equal to 0, this if is nested in outer if. So this is possible. If num%3 equal to 0, then if this condition is met, we will print a message that number is also multiple of 3. Otherwise, we will print the message that not multiple of 3. If in case the outer if itself evaluates in false, then directly the outer if's else, which is an indentation of the outer if, that is in the second last line, that will be executed, which will print not a multiple of 2.